Am I live? Right, so let me just check if I'm live, okay? Am I? I'll just check it. Yes, I'm live. So, good morning, good afternoon, good day to everybody. Today I'm going to talk about indices or the index laws. If you can see on my screen, I've got here 6 to the fourth expression or number. 4 here is the power and 6 is the base. What does it mean? That you're going to multiply 6 4 times. So you have 6 times 6 times 6 times 6, and you call this 6, 6, 6, and 6 as the factor form. If you multiply all these numbers together, then, or multiply one after the other, then you get a basic numeral 1296. The 4 here, this little one, is called the index, right? That's the index. Let me just change the thickness. Right. You call that the power or the index or exponent. That will tell you how many times will the base of the number be multiplied. So if you have 6 to the third power, then it means that you're going to multiply 6 by 6, 36 by 6, then that will be the answer. So 36 times 6, 36 times 6, because this 2 here will give you 36, and the result will be multiplied by 6 again. So for quick or for mental maths, you can break the 36 into 30 and 6, right? And multiply 30 by 6 and 6 by 6 as well. So you will get a result of, without you using the calculator. So 30 times 6 is 180, and 6 times 6 will be 36. Then add these two together. So you have 0 plus 6 is 6, 8 plus 3 is 11. You put 1 in there. 1 plus 1 will be 2. So that is 216. Now let's check from the calculator. So you have 6 times 6 times 6. It's 216. Doing it mentally is even faster than using the calculator. Okay, so the first index laws that we're going to deal with will be the a to the m times a to the n. If the bases are the same, then the exponents must be added. Now, many times the students make mistake in here. They add expressions when the bases are not the same. You have to take note that a's here are the common base and we are doing a multiplication. So to give you an example, if we have x to the second power and multiply it to another x, third power, then you just have to copy the common base, and the common base is x. And what will you do? You add the exponents, which gives you 5. So x to the second power multiplied by x cubed gives you x to the fifth. You have to add exponents. Let's have another example. if I have z cubed times z to the negative 2, so I am incorporating a negative exponent. So this will be, because you have a common base z, then you just have to copy z down here, and you have to add 3. You have to add 3 and a negative 2, right? So 3 plus a negative 2, the negative and the positive here will be converted to a negative sign. Therefore, you have z 3 minus 2. 3 minus 2 will give you 1. So this will be z to the first power, or when it's 1, you don't let that 1 appear anymore. So you only have z instead. Okay? So remember, when you have expressions where you are asked to combine them with a common base, then you just have to add the exponents. We'll move to the next. Oh, hang on, before that. What if you have all variables p to the r times p to the 2r? What happens? Then, because it's a common base, then you just have to write p, okay? And add the two exponents. So you have r plus 2r gives you 3r. So the answer would be p raised to 3r. That's the answer. It's the same when it's negative. So when it's negative, you do p to the 2r times p to the 3r. Then you will have p, and you get the difference, the sum of the two, 2r plus 3r. The answer would be p and 5r. That's the answer. Okay, p to the 5r. But if it's negative exponent, then of course, it depends on which one is greater. Right, let's move to the second law. The second law is a quotient law. The first one is product law. So if it's quotient, you get the difference of their exponents provided that the base are common. Okay, their bases are common. So to give you an example, then let's say we have an x in here. X to the second power divided by x to the third power. So what shall we do? We get the common base x, and the upper exponent to, that's always the arrangement, 2 minus